Hello world, Christian Truther here again, and this is my second part of a multi-part video series on examining the shape of the world. Is it round? Is it flat? We're looking at the geocentric versus heliocentric debate, and we're looking at it for objective truth. Truth that is true regardless of what we think about it, and we want to hold on to that objective truth. Now, if this is the first video you're catching of mine, I highly recommend going back and watching the first, because I go over why I'm even doing this, and I also tackle a completely different subject matter. So highly recommend it. All my videos are going to be about 10 minutes long, and as always, there's no glitz, no glamour, technological wizardry, or scripts. I'm not doing any of that because I don't think that my argument needs the help. I just want to be able to present what I have discovered and what I've reasoned out and what I've experimented out on my own. And now, as always, there are some ground rules. I hope you can read them. I'm not going to read them out loud. The first two are going to be my promise to you, and the bottom two are going to be what I hold you accountable to, especially in the comment section. But just stick with me for a little while because it's going to be a pretty short trip. But this video is going to be dedicated to satellites versus wandering stars. What are the lights that we see in the sky? And we can see lights in the sky unaided. We're going to take each argument and we're going to aim the biggest guns we can at each argument, and we'll see which tower falls. Okay, so let's start out with the accepted model. The accepted model is the heliocentric one that says these lights were not ever described by the ancients. They can't find anything in the ancient literature, even amongst cultures that were very interested in stars, like the Greeks. The closest you could get to is comets, but it doesn't really work out to be the same thing. You know, comets look very different than, even to the unaided eye, than what these lights we're seeing moving around are. So the fact that they weren't described before would be evidence that this is indeed satellites that we're placing up in orbit. Now, this is not exactly complete concrete evidence, but it is a persuasive argument. But let's take a look at the other side. From the flat Earth model, of course, satellites are a real problem. So what they say they are is there is a wandering stars up there. We don't know exactly what they are, but they cannot be satellites because the space agencies, like NASA, claim they're placing satellites in what's known as the thermosphere, especially the most famous satellite probably, which is the International Space Station. Hubble could be, but I'm going to go with the International Space Agency, the International Space Station, ISS, as the most popular satellite placed up there. I didn't take a poll, but I think it probably is. And they place that in the thermosphere, and the thermosphere's stated temperatures, 4,000 degrees Fahrenheit, are well above the melting point of most of the materials that NASA claims to have used in the construction of the International Space Station. So therefore it makes no sense that this structure would be up there. It's all a big lie. And this is a very good argument against the International Space Station and similar satellites placed in that region of space. So beyond just saying, you know, the world's flat and has a dome roof and therefore we can't put satellites up there, which is not really an argument. It's an argument that only stands upon itself. This is a very convincing argument on why the NASA explanation doesn't make sense. So does NASA have a rejoinder? Well, we better hope they do if they want to stay in this fight, because otherwise this video is over. Well, they kind of do. So let's take a look at that International Space Station. Because not only is it probably the most popular, it's easily the biggest, and it's got a very discernible shape to it. So what do we see in our night sky, or sometimes during the daytime? Well, here is someone who took a picture of something going across the sun. It's got a very discernible shape, and you know what? They've got a really good camera rig. They've got an excellent solar filter, and it's a very clear shot of the International Space Station. I probably couldn't duplicate that as of right now. I would definitely need to get a solar filter for starters before I'd even attempt such a thing. But here's a night shot that I probably could duplicate. Here's it transiting in front of the moon. And again, it's got that very discernible shape to it. So something is clearly up there, and it matches NASA's description of the object. I say I could probably get this because I've taken this shot of the moon. No ISS in front of it, but roughly the same magnification level, and I could probably get it with the camera equipment I have currently. So maybe I'll try that sometime, but I do need to know when it's transiting and make sure that I can be supposedly in line from it to the moon. So there is something up there, and it does have a very recognizable shape, but what is it really? Well, NASA started off with the beginning of the International Space Station program. I remember this argument back in the 90s when Skylab was our major, quote unquote, um, laboratory in space, and we were going to be decommissioning it, and we're going to be working with other countries to create a space station that they can go on board. And should we do this? And it's a whole lot of money, and couldn't we just resurrect, Skylab some more, give it. Well, all these things didn't matter because in the late 1990s, they started claiming to send up the parts for International Space Station. And lo and behold, a structure started to take shape in our night sky. A structure we had not seen before. One that NASA predicted in advance would be there. One that took the shape that NASA predicted it would take. And one that was not described by any of the ancients. And again, this is not straight up evidence, but it is very convincing that one, they knew what was going to be there before it was there. And two, they predicted exactly when we would start seeing it. We started seeing it at that point. And it changed shape as modules were added, and we were able to even detect that with a good zoom lens as the structures started to take shape. So certainly NASA knows what it is. NASA absolutely knows what it is. Whether or not they're lying about it, about them putting it up there or not, they absolutely do know what it is and knew about it in advance. So again, this is more evidence, but it is not concrete proof. They need to get past this thermosphere argument. So the thermosphere is indeed about 4,000 degrees, and that would melt down most of the materials if you put them in a furnace of that temperature. But NASA argues, no, the thermosphere is very sparsely populated by any particles of the atmosphere. That the atmosphere thins out at that region, and it's close to a vacuum. Not perfect, but it's very close to a vacuum. And that furthermore, they chose the components that they used to prevent them from going to molten slag, that they would give off energy in the form of infrared heat. Okay, that's all the infrared light spectrum is heat. And they would give off that energy once they reached an equilibrium that temperature equilibrium was well below their melting point. Okay, well, does this make sense? Can we think of anything? First of all, there are three types of methods of transferring heat. One is conduction, which is how we're saying the International Space Station would be bombarded by high energy, high heat particles in excess of 4,000 degrees, and the energy from those particles would conduct to the space station itself. If you've ever touched a hot surface and your finger got warm, that's what happened, was conduction. There's convection, which is when you can take a gaseous or liquid substance and it's got cold areas and hot areas, and you swirl it together, which, by the way, cold is not really a scientific term. We have areas of higher and lower relative heats. But just to use the common vernacular, you swirl it around like a bathtub water where you had mostly it was filled with cold water, and you turned on the hot tap, and then you swirled it around, and it became a more uniform, higher temperature body. And then we've got radiation, which sounds scary, but isn't really all that scary. That's what light is. Light radiates away from the source, and that is another way that energy is transferred. And this, by the way, is how NASA is saying this works, but it's doing it in the infrared. Well, does that make sense? And the answer is yes, because we can come up with, in our minds, a substance that is constantly getting energy added to it in a near vacuum and radiates light. It's the incandescent light bulb. All right, and they're saying that's the exact same thing that's happening over here. Tungsten is continuing getting energy, but it doesn't melt down because it's radiating its energy away in the form of light. Well, they're saying the same thing is happening with the International Space Station, only it's the form of infrared light. So, the thermosphere is not all that scary according to NASA because it's very sparsely populated by these high energy, high heat particles, and so the International Space Station isn't being raised up in temperature too fast for it to reach an equilibrium well below the station's melting down points where it's radiating energy away in the infrared. So, the light bulb is the answer. It's the solution, and it's one that makes sense. NASA's answered all the problems with the station being able to exist in the thermosphere in a manner that makes sense. Now, this is, again, not concrete evidence that satellites are absolutely what they say they are, but they certainly do know what they are because they predicted them in advance, and they have an explanation for them to continue to be there. So we'll take a look more at satellites next time. I'll only do one more segment on them, but we will take another look at satellites. But for right now, the balance seems to be tipping towards the round Earth model. We'll continue next time. Christian Truther, signing out.